In this video we are going to discuss about the built-in self-test. So on completion of this topic, students will be able to understand the built-in self-testing and the architecture as well as the application of IC. In built-in self-test, it is a design for testability technique that places the testing functions physically with the circuit, and also this requires the addition of three hardware blocks to a digital circuit, that is test pattern generator, response analyzer and test controller. So here this generates the inputs to combinational logic and combine the outputs into synchrone. With a high probability there will be the block which is fault free, which produces unexpected synchrone. The major components which is present in this built-in self-test are hardware pattern generator, test controller, output response comparator, ROM and comparator. So examples of this pattern generators are stored patterns counters and the linear feedback registers, which is used for the stored responses, and also this compacts and analyzes the test responses to determine the correctness of the code. So based on the responses of during testing, this will be corrected automatically, that we call it as built-in self-test. So here in built-in self-test, the wires from the primary inputs, that is from the mux, and the wires from the circuit uh, output to the primary outputs cannot be tested by the Bist. So in normal operation the cut receives its inputs from the other modules, and it performs the function for which it is designed. So during the testing mode, this test pattern generator will apply a sequence of test patterns, and the test responses are evaluated by the output response comparator. In most common type of the Bist, these test responses are converted into the output response compactor, and the signatures are compared with the golden signature which is present or which are stored on the chip, and the error signal will indicate whether the chip is good or not. So the four primary factors must be considered in developing this Bist for the embedded system. The main thing is fault coverage, test set size, hardware overhead, performance overhead, and the issues which are present in the Bist are, that is area overhead. There is additional active area due to the test control or pattern generator, response evaluator, and testing of this are mainly due to area overhead, pin overhead, performance overhead. Then there will be some loss in the yield. Next, design will be comfort and the time may be increases. So these are the things which are used in the Bist. And boundary scanning, these testing boards are difficult. They needs to verify either it is good or bad. So drive a pin to 0 then to 1. So check all the connected pins and give the values through the hold boards. We can use the bed of nails, so we can easily connect the pins, and building capability of observing and controlling these pins will be more easier, and it reduces the testing and maintenance cost as it requires simple and less expensive. This significantly reduces the cost of automatic test pattern generation. Also, the main thing, it reduces the storage and maintenance of test patterns. It can test even many units in parallel. Also, take a shorter test application times. Also, functional speed is very high. In this boundary scan, there is a testing which provides a means to test interconnects and clusters of logic, etc. So here this adds one or more test cells which are connected to each pin, and also it can selectively override the functionality of each pin. These pins, which are arranged through the chains, are driven to a signal on this across this place. There will be a programmed board, so that it reads the value of the pin and verifies the board properly and connects these two pins. So while seeing this chip infrastructure, This provides the boundary scan capability, and if these cells are connected together to form the external boundary scan shift register, and this combined and provide with a control circuitry. These pins can allow the integrated components to be tested, and if they were separate chips, uh, they were used for the several internal scan issues. So these interfaces boundary scan, which is access to the 5 points, are test clock, test mode select, test data in, test data out, test reset. In that, test reset is optional, and the chips with the internal scan pins can access the chance through the boundary scan for unified test strategy. So the overall summary is, these designs are used the testing from the beginning, and also this should be simulated as you go. Then planning should be taken after fabrication. If does not, it won't work. So for normal operation, the added boundary scan latches are set so that they have no effect on the circuit, and therefore it is effectively invisible. Once a complete data bed has been shifted into the circuit under test, it can be latched into place so that it drives to the external signals. Quiz questions on Bist. Random logic is probably best tested through dash. Thank you.